Okay, class. So today we're going to go over chapter 21, which is entitled "The Monetary Policy and Aggregate Demand Curves." So just to review a little bit, what we did last time in chapter 20 was to derive the IS curve, which gives us a relationship between interest rates and output, real interest rates and aggregate output. So, and what we found was that there was a negative relationship. Okay. Ultimately, after chapter 21 and chapter 22, our goal is to derive two relationships between output and inflation. And what we will derive is what we are going to call the aggregate demand curve and the aggregate supply curve. Because the goal of monetary policy is to guide the economy to an appropriate level of real output here and inflation. Okay, high inflation is a bad thing and low output is a bad thing. So the goal of monetary policy and the Federal Reserve is to help guide the economy to an ideal combination. Monetary policy doesn't do it alone. There's also fiscal policy, but in this course, and we will bring that out, but in this course, we go into monetary policy in detail. So here's what we did in chapter 20, the IS curve. And we're going to try and move from the IS curve to the aggregate demand curve, this one. Now, as you see, the IS curve is a relationship between this is real interest rates, after taking out inflation and output. Somehow we want to have the aggregate demand curve be a relationship between income and inflation. By the way, pi is inflation. Okay, so the IS curve is a relationship between income and real interest rates. We want to transform that into a relationship between real income and inflation. So, how do we do that? Well, we'll take into account another relationship. And that is the monetary policy curve, MP, monetary policy. And we're going to assume and explain that monetary policy, the the Federal Reserve Board follows a monetary policy such that oops, sorry about that. Monetary policy such that there's a relationship between real interest rates and inflation. In particular, given a level of inflation, the Federal Reserve tries to set or can set a real interest rate. And this is a positive relationship. The higher the level of inflation, the higher the real interest rate the Federal Reserve sets. So this is our monetary policy curve. Okay. So how do we get from, we use this relationship with the IS curve to derive our aggregate demand curve. Okay? First, let's see what's behind this monetary policy curve. Okay? So if you look at page 501, sorry about that, all my little stuff. 501, monetary policy is this, the Fed follows a rule such that the real interest rate equals a certain constant plus some function of inflation. Now, if you remember back in chapter 16, we didn't study everything in 16 in detail. It was very long, involved chapter, but we did emphasize the Taylor rule. And what the Taylor rule says is that the Federal Reserve sets the federal funds rate equal to an inflation rate plus the equilibrium real rate plus 1/2 the inflation gap plus 1 plus 1/2 plus 1/2 the output gap. Now, the inflation gap, here I'm looking at page 394. The inflation gap equals current inflation minus the target rate of inflation and the output gap equals current GDP minus potential GDP. Okay. So, in other words, the higher the inflation rate, the higher the federal funds rate is supposed to be set. The higher the inflation gap, again, the higher the federal funds rate. And the higher the output gap, the higher the federal funds rate. Why do we set these parameters this way? If you have high inflation, you want to reduce that. You do that by raising interest rates, and that will reduce investment, lowering output, and reducing inflation. Similarly, if aggregate demand is greater than the current potential output, to slow that down, you raise interest rates. Okay, so now this equation looks like a vastly simpler equation than this, and in particular, we don't have this output gap here is current income minus some target known potential income. We don't have income in this equation. So what's going on here? How can we say this is the monetary policy rule and this also is the monetary policy rule? What happened to income in this equation? What happened to the inflation? Why do we have real interest rates in this equation? Okay? As opposed to, remember, the federal funds rate is a nominal rate. It's not real rates. Remember the relationship between real, let's put it this way better. Remember we said nominal rates, say I, some kind of nominal rate equals a real rate plus the rate of inflation, or expected rate of inflation. Okay, so how do we reconcile these two equations? Well, first we could take the federal funds rate and subtract the inflation rate from both sides. Okay. Then we have some equilibrium real rate. And some function of the inflationary gap, which we said was pi minus some target pi. Okay. And some output gap. So what we can do, since we want this relationship, a relationship between the real rate and pi, because we want to graph this relationship, the monetary policy, we want to graph it in this real rate pi space. We're going to subsume one particular value of the output gap into and combine that with the equilibrium real rate, and also take this target inflation rate and also combine that with the real rate. Put all that stuff together into this R bar. Okay, and as any component of the equilibrium real rate, the target inflation rate, or the output gap changes, that's going to cause a change in the shift. It's going to cause a shift in our monetary policy curve. Right away, on the other side, we see that this federal funds rate, which is a nominal rate here, like I, and when you subtract the inflation rate from the federal funds rate, you're left with a real rate of interest. That's why we subtracted that out. So now we have a relationship between real rates and some target real rate and some function of inflation. So that's how we can reconcile these two equations. Okay, I mean, it's a little, I'm sure that's a little confusing for you, but I needed to go through that exercise myself. I saw this equation popping up in chapter 21. It was the monetary policy rule now, and I remembered that in chapter 16, this was the monetary policy rule. How did it change? How did it go from this rather complicated equation to this rather simple equation? And now I've satisfied myself how that occurred. Okay. Oh my God. Okay, so here we are on page 502. And we've explained how we have this relationship R equals R bar plus delta pi, and we've shown how pi is delta is a positive number, and so there's a positive relationship between inflation, pi, let's write that down here, and the real rate R, and here it is graphed. So for example, if we take R bar equals to 1 and delta equals 0.5, we can graph that specifically in the inflation real rate space here. So for example, when pi equals 1, we would get the real rate equals a half plus 1, or 1.5. That gives us point A. When pi equals 2, let me do it specifically. When pi equals 2, we have R equals 1 plus a half times 2 equals 1 plus 1 equals 2. 2, 2. And similarly, when the inflation rate equals 3, the real rate, as said by the Fed, equals 2.5. Okay, so now we have our monetary policy curve, and as a function, as R is a function of pi. Okay. So here I'm looking at page 503, and we're going to show how the monetary policy curve can shift. So for example, if the Federal Reserve thinks that inflation, suppose we're at here, if it thinks that inflation is too high, or if output is increasing too much, it wants to tighten monetary policy. It does that by raising the real rate, raising its policy instrument is the federal funds rate, which is a nominal rate. And so when it raises the nominal rate at any particular rate of inflation, the real rate is going to be caused to rise. So at any particular point of inflation, the real rate will rise. And we show that by a parallel shift. In the monetary policy curve. So this is a tightening of monetary policy. If there's a fear of recession, the Federal Reserve is going to want to lower the real rate. It does that by increasing the money supply, which lowers interest rates, at any particular inflation rate that has the effect of lowering real rates. So that's a parallel shift down of the money supply curve. And this is easing. Monetary policy is loosening and becoming more easy. Okay. So now we see how the autonomous policy changes are reflected in a shift in the monetary policy curve. Now that's differentiated by if inflation moves, let's say inflation is at 2% initially, and the monetary policy rule is to set the real rate at 2%. If inflation moves up a bit, the Fed is going to follow its rule and move along its curve. Okay? Or if inflation falls a bit, the Fed is going to reduce the real rate along the curve. That's not an autonomous shift in policy. An autonomous shift in policy is when the Fed decides it doesn't like the current inflation rate for some reason, or there's a fear of recession and it wants to change monetary policy at any given inflation rate, and that is done with a shift either up or down in the monetary policy curve. So now we're ready to tackle the big figure graph in the chapter. It's on page 507. It shows how to derive the aggregate demand curve from this is our IS curve right here. Whoops. This is the IS curve. This is our monetary policy curve that we worked with on the other page. We're going to combine these two curves and derive the aggregate demand curve. Okay. So, let's say inflation is 1%. Oh, I didn't put my values here. Let me put my values. This is 1.5. This is 2. This is 2.5. This is 1, 2. Okay, this, of course, you're going to have to go over this a little bit. I mean, what we're trying to do is take two equations, each of them in two variables, but the two variables, there's a total of 3 variables going on here. And we're taking one equation and two of the variables, another equation in two of the variables and sort of substituting out one of the variables to come up with this relationship in two variables. In other words, here we have a function of r and pi. Here we have a function of r and y, and we're going to end up with a function in pi and y. Okay, so here's how we do it. Start with the inflation rate of 1%. The Fed is going to try and set a real rate of 1.5. Okay, so now we have a real rate of 1.5. Go over here on this IS curve. At a real rate of 1.5 here, equilibrium in the economy is going to occur when output is at 10.5 right here. Okay? So we can summarize this position as aggregate output of 10.5 here and occurring at a inflation rate of 1%. So here's our inflation rate, here's our 1%. So this is position 1, this is position 1, and this is position 1. Okay? A little confusing, but it's done this way because we're trying to graph. Essentially, the problem is we have three endogenous variables. We're trying to graph them in on a XY coordinates, so somehow we have to eliminate one of them. For point 2, suppose there's an inflation rate of 2%. This is point 2. The Fed wants to set a real rate of 2%. Go over to your real rate here of 2% on the IS curve. You find that the equilibrium output in the economy is 10.0. That's point 2. Go down to your aggregate output, your aggregate demand curve. Aggregate output of 10.0 is here. That's point 2. And we graph it at an inflation rate of 2 because we started out here with an inflation rate of 2. Okay. Finally, at an inflation rate of 3.0, we go up here to our monetary policy curve. We see that the Fed is going to set a real rate of 2.5. We look here on our IS curve at a rate of 2.5 here. Equilibrium output is 9.5. So we look here at 9.5, and we know we started out with an inflation rate of 3, which is here. That gives us a third point. We graph these 3 points, and it's a relationship in the monetary policy curve and the IS curve. We call that the aggregate demand curve. Okay. Very good. So you can work that out and compare that derivation with what the text how the text explains. So now we're going to see what happens when the Fed changes policy. Okay? So, or when the government changes policy. So in general, the government, if it wants to influence the economy, it has two tools. One is fiscal policy and monetary policy. So we're looking at page 509, and this is an example of what happens when when government spending increases. Okay? So, if you remember from chapter 20, we showed what happens when government spending increases, and remember, okay, so what happens? Remember, this middle section is the IS curve. When government spending increases, what happens? There's an autonomous shift. There's a shift in the IS curve to the right. To the right. Okay? So let's do that. Okay, so let's do that. Let's draw that in. So we're at a real rate of 2%, let's say, to start. The shift it would be at any, we can see what would be the equilibrium output at any rate, but let's say we'll first look at 2%. So 2% equilibrium output would say increase to 12.5. And remember, this is our IS curve. So now to graph it on our aggregate demand curve here, when government spending increases, G increases here, we now have a point down here. Inflation hasn't changed yet, At the initial inflation rate, say of 2%, output on the AD curve would go up to 12.5%. And we can see that each parallel change in the IS value would result in a parallel change in the aggregate demand curve. Okay, so we're going to end up with the new aggregate demand curve over here. So initially, this was, initially we had an IS curve over here and an aggregate demand curve here. We have a shift in the IS curve. That's IS prime. IS will result in a shift in the aggregate demand curve. Okay? It's a lot to memorize, but if you go back to basics, an increase in government spending, we worked out last week in chapter 20, that would result in a shift in the IS curve, and then causing equilibrium output to increase. And so when you go to your aggregate demand curve, at each inflation rate, you would increase output similarly, and you end up with your new aggregate demand curve. Okay. And so you can go through all the various possibilities of shifts of the IS curve. If taxes increase, you're going to have a shift this way. If autonomous consumption increases, you're going to have a shift this way again. You can go through all the examples, and the IS curve will shift appropriately, causing a similar shift in the aggregate demand curve. Finally, we can see what happens when monetary policy changes. So, I'm looking at page 510. Say the Fed tightens monetary policy, its monetary policy, as we saw just a while ago. That has the effect of shifting the monetary policy curve upwards. So that's our curve up here. Okay, so we have a shift up because we have a tightening of monetary policy. That's an increase in the real rate at every rate, the real rate at every rate of inflation. So this would be MP1 or prime. This is MP, the original, we could say MP original. We have a shift up in the monetary policy curve. And so at the original inflation rate, the real rate of interest will rise. Let's say it rises to 3%. So to find equilibrium income, we go to, let's do this. Let's make this nicer. Let's make this nicer. Rise, a tightening of monetary policy at the initial inflation rate, the real rate would rise to 3%. We go to our IS curve here. And, whoops, very good. We read off 3%, which would be up here. We erase this a little, clean this up. This is our real rate. Let's clean this up a little bit. %3 would be here, and we read off what the equilibrium output would be. Let's say that's 9.5. Okay. Okay. The IS curve hasn't changed. Monetary policy, we find a shift in monetary policy. So equilibrium income would be on our original IS curve. It would be 9.5. So we take that down to our aggregate demand curve here and say that now at our original inflation rate here of 2%, we now have equilibrium income at 9.5, which is here. And we could do that at each inflation rate. At an inflation rate of 1, we find a higher real rate. At that higher real rate, which would be over here, we find higher income, and that would give us a point over here where the higher income and the lower inflation rate, which we were talking about, would be over here. Why did I put a 3? Okay, let me back up. That's a little bit of a mistake. This, I'm not going to re-record this, but before we went from we had an inflation rate of 2%, real rate went to 3%. We read off our real rate of 3% on the IS curve. That gives us our new equilibrium output of 9.5. So the new point in the aggregate demand space is 9.5. Remember, I made the mistake of using the real rate here. This axis is the inflation rate, okay? So we go back and get the inflation rate here, 2.0. Okay. So inflation hasn't changed yet. So we get that point with the inflation rate of 2.0. If we were at 1% and monetary policy tightened, we would get a point here, real rate, say of 2 and around 2, with a real rate of around 2, we might have be less than 2. Let's say 1 3/4. If we had a real rate of 1 3/4, we would get a output level of somewhere higher than 10, and so that would be a point over here. And this point would represent our output level that we get from the IS curve here. With the inflation rate here of 1.0. So that's how we get this point. Graphing these two new points we have our new aggregate demand curve. Okay, so we've seen how monetary tightening results in a shift of the aggregate demand curve. Okay? So please go over this. Go read the chapter 21 in the book. And I know it's a little complicated to absorb, especially if it's the first time for you guys. So please send me questions if you want me to do this analysis again. And you should try and imagine what would happen if there was other exogenous changes. For example, what would happen on this graph if we had monetary easing? The Fed eased monetary policy. How would you represent that? Okay, thanks for listening.